Good day, my dear students. Despite all the challenges that we encounter nowadays, we're still here. Welcome to our Google Classroom. So, last meeting, we discussed about continuity function. When can we say that a function is continuous or not? Given an interval, given a specific domain, or continuous at a point. So, last meeting, we discussed about continuity function at a point. So, in order to determine if the function is continuous or not, first, we might be able to have a graph of the function. But the problem is, if we cannot graph the function, how can we determine if the function is continuous or not? So, in order to do that, or in order to solve that problem, we have to satisfy the three conditions. This is what we call continuity test. The first condition is f of a exists. So the assumption here is we know the function. Then we have to satisfy if f of a exists. What is a here? A is actually the value of our x. It's the input value. It's the input variable. The second condition is we have also to satisfy if limit of f of x as x approaches a exists. Okay? Now again, these three conditions must be satisfied. So in other words, if the first condition is not satisfied, then we can already say that the function is not continuous. Now, if the first condition is satisfied, we have to continue satisfying the second condition. That is finding the limit of f of x as x approaches a. And we have to determine if it exists. Then the third condition, the first condition and the second condition must be equal. In other words, f of a must be equal to the limit of f of x as x approaches a. Okay? So, since the third conditions or the three conditions are already satisfied, then we can say that the function is continuous at a point A. Okay? Now, so for example, if we are given f of x is equal to the absolute value of x over x. Okay? This is our given function. The question is function f continuous at x is equal to 0? Some of you here, if the method is not specified, then maybe some of you here will just graph this given function in order to determine if the function is continuous at x is equal to 0, right? Now, some also would just use the three conditions or the continuity test. Okay, so the goal of this topic is to use the three conditions. We have to use the continuity test to determine if this function is continuous at 0 or not. Now, in order to use the three conditions, or in order to satisfy the three conditions, we have to satisfy the first condition first. Okay? Using continuity test. First condition is f of 0 exists. That's the first condition. We have to satisfy if f of 0 exists. Now, if we are going to look at the given function has an absolute value. So in order to find the value of this, because if we will directly or we will substitute immediately the 0 in this given function, we come up with 0 over 0, which is indeterminate form, or which is undefined. So in order to solve or satisfy the three conditions, we have to simplify the given function. Take note, the absolute value of x. We have the important property of absolute value. This is given by the absolute value of x is x if x is greater than or equal to 0. Now, this is negative x if x is less than 0. In other words, we have two possible values. X if x is greater than or equal to 0, negative x if x less than 0. So, in other words, the given function can be redefined. So we have x over x, because the absolute value is x siya if x is greater than or equal to 0. X over x, which is equal to 1 if x is greater than or equal to 0. Now, negative x. So this absolute value is also negative x if x less than 0. So we have negative x over x, which is negative 1 if x is less than 0. Now, we were able to get the equality or the redefinition of f of x, the original function. In other words, if you're going to sketch the graph, obviously, the graph looks like this. So, graph natin, 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3. We're going to graph this one. 1, if x is greater than or equal to 0. Okay, if x is greater than or equal to 0. But we have to take note, 1 siya. Where is 1? 1. If x is greater than or equal to 0. But no, sorry. 1 if x, by the way. 1 if x is greater than or equal to 0. Okay? Where's x greater than or equal to 0? Ito. But the original definition of absolute value, it must be equal to 0, greater than or equal to 0. But in this case, it should not be, because if x is equal to 0, it will be undefined. So it is strictly less than 0. Okay? So if this is less than 0, and the value of f is 1, so if x is greater than 1, it's 1. If x is less than 0, it's negative 1. So, in other words, class, this is our f of x, which is equal to the absolute value of x over x. So, by just looking at the graph, we can really say that the function is discontinuous at 0, 0. Why? This is discontinuous from the right, and also discontinuous from the left. And there's also a jump discontinuity here. Okay, so by just looking at the graph, we can really say that the graph of the function is discontinuous. But if, assuming that we will not be able to determine the graph of the given function, so that's the time we will use the continuity test. The continuity test, let's go back to the first condition, f of 0 exists. Now, if f of 0 exists, f of 0 exists? No, does not exist. Why? Because in the first place, f of 0, there's no f of 0 here because what? F of 0 exists? No. What? Because it's undefined if x is equal to 0. Okay? So, since the first condition is already dissatisfied, then we can say, since the first condition is not satisfied, then f of x is equal to the absolute value of x over x is discontinuous at x is equal to 0. If there's another question, okay, determine the type of discontinuity. Determine the type of discontinuity, class. The type of discontinuity is what? A jump discontinuity. Bakit? Because in the second condition, limit of f of x, since this is a piecewise defined function, so we will be able to determine the left-hand limit and the right-hand limit. What's the left-hand? The left-hand limit. As x approaches 0 from the left, it is equal to -1. Well, this limit of f of x as x approaches 0 from the right is 1. In other words, limit does not exist. Okay? Since limit of f of x as x approaches 0 from the left is not equal to the limit of f of x as x approaches 0 from the right, because this is equal to -1, not equal to 1. In other words, therefore, limit of f of x as x approaches 0 does not exist. Okay? And our clue, if the left-hand limit and the right-hand limit, they're not equal, therefore, we have a jump discontinuity. A jump discontinuity. Okay? I hope you understand the continuity function given this first example. So, the next example will be given later. Thank you and have a good day.